Okay, stats, this last section is all about counting. The fundamental counting principle says the number of ways in which a series of successive things can occur is simply the product of the number of ways each individual choice can occur. What does that mean? Well, if you roll a fair dice and flip a coin, a fair dice has 6 options, a coin has 2 options, so between the two of them, you have 6 times 2, or 12 options. You just multiply the two separate pieces. As an example, you have 2 pairs of jeans and 3 shirts. How many ways can you make an outfit? 2 pants, 3 shirts, 2 times 3 is 6. It's really that simple. How many different ways can you order one of each? You have main course, veggies. One day I will fix this. Every year I laugh at it. Drinks and desserts. Looks like you have 5 main courses, 6 veggies, 4 drinks, and 3 desserts. You simply multiply all of those together to get one order of one of each. Looks like that's 360 ways. So basically one for every day of the week. We'll do one more example of this because it can get a little more complicated. So we're going to skip number 2. You can do it yourself. Number 3, you're taking a multiple choice test with 6 questions. Each question is 3 choices. How many ways can you answer each of the question? Now don't assume because you have a 6 and a 3 that you're going to multiply those 2. Each question is a separate choice with outcome. So we've got 3 times 3 times 3 for each of 6 questions. Now we wouldn't normally write it out like this. We would normally write it as 3 to the 6th, which is what I would suggest you do. 3, 9, 27, 81, 243, 729 different ways to answer a 6-question test with 3 questions each. Now what if you could leave it blank as a possible answer? Instead of 3, you now have 4 options, any of those 3 plus leaving it blank. 4 to the 6th is 4, 16, 64, 256, 1,024, 4,096. A lot more different ways. A garage door opener will have with a 4-digit code entered into a keypad. It has one. How many codes are possible? Digits go from 0 to 9, so there are 10 of them. It should be 10 to the 4th, or 10,000. What is the probability of getting it on your first try if you can't remember it? That would be 1 out of that 10,000. Not great. Try things like 0000 probably. But if you made that your gate password, or your garage password, you're asking to be broken into. Okay. So next we're going to talk about permutations and combinations, but before we do that, we have to set up a concept. Now, your calculator will be able to do permutations, combinations, and factorials. I would Google how to do it with your particular type of calculator. A factorial, for example, 7 factorial, is 7 times all the other whole numbers down to 1. So 7 factorial means 7 times 6 all the way down, times 5, times 4, all the way to 1. It's a lot of numbers. It gets out of hand very quickly. If you look at this, this is already 5,040, and we only started at 7. So write these out and evaluate. I'm going to do one of them. 5 factorial is 5 times 4 times 3 times 2 times 1, and it's 120, but I'll leave the others for you to do. Now, a permutation is an ordered arrangement such that no item is used more than once, and the order makes a difference. For example, if you have like 7 people competing for the gold medal in the Olympics, gold, silver, and bronze, and how many ways can different people arrive on the podium? Well, does order matter? Is getting first and getting the gold medal the same as getting third and getting the bronze medal? No, it's not the same, so the order does matter. So the number of ways that this can happen, generally speaking, is the number of ways to choose item 1 times item 2 times item 3, etc. And you probably think that we just did this with the fundamental counting principle. We'll look at a separate way to do it on the next page. Because generally speaking, permutations and the fundamental counting principle can be interchanged. Think about this problem. A Little League baseball team has 13 players. The code says to choose a batting order for 9 of the players. How many different ways can you make a batting lineup? Well, you have 13 choices, then 12, 11, 10, 9, 8, 6, 5. Now notice, this looks like that factorial thing because we're starting with a number and multiplying by all the numbers beneath it. But notice that we stopped at 5. In order to get a factorial to stop, you need to divide by all the numbers underneath it. So the next number that I would have had is 4, so I needed to divide 13 factorial by 4 factorial. That's the general form for a permutation. A permutation of n things taken r at a time, which is called NPR in your calculator. This is how you know how to do a permutation. In your calculator, you'll put a number like 13. You'll find the NPR button and then put 4, and it will spit out your answer for you. 13 batters taken 9 at a time. That's 13, the total in the numerator. 13 minus 9 in the denominator, factorial. 13 minus 9 is actually 4. So these are the same thing. Evaluate each of these. 7, we'll do 1. Actually, we'll do them all. 7p3. So the first number goes in the numerator. You take the difference, 7 minus 3, and that goes in the denominator. So 7 factorial divided by 4 factorial, or 7 times 6 times 5, 210. 8pr. Well, this is awkward. 8 factorial over 8 minus r factorial. Since we don't know what r is, there's no evaluating. We have to leave it. 6p0. 6 factorial over 6 minus 0 factorial. 6 factorial over 6 factorial, which is 1. Why is it only 1? If I told you you had 6 items and you have to put 0 of them in order, how many different ways could you put 0 of an item in order? Well, 1. You're not doing anything with them. We'll skip number 4 and go to the next page. "20 equally qualified friends are going into business together. They need to pick a CEO, an operating manager, and a treasurer. How many ways can they pick these?" You have to ask yourself, is being the CEO and the treasurer the same thing? No, so the order matters. There are 20 people. They're picking 3. So 20 minus 3 goes in the denominator. This means 20 is multiplied by all the numbers underneath it, all the way down until you hit 17. So 20 times 19 times 18, and then I would have hit 17, so I stop here. So we ask ourselves, what is this? I believe this is 6840, but let's check just to make sure. Yeah. There's 6,840 different combinations. We'll skip number 6. Do number 7. How many ways can you rearrange the letters in the word combine? Okay, so you have 7 different letters, and you're picking all 7 of them to rearrange. 7p7, so 7 factorial over 0 factorial. 0 factorial is 1, so this is just 7 factorial, which is 5,040. Lastly, how many arrangements can be made using 4 of the letters? So instead of using all of them, we're only using 4 of them here, which is 7 factorial over 3 factorial, or 7 times 6 times 5 times 4. It's 42 times 20, 840 ways. And we'll continue in the next video.